In a previous video, we put together the hardware for this simple Arduino controlled robot. In this video, we're going to cover some of the basics of working with the Arduino and explain some of the software to get some LEDs blinking.
We load software onto the Arduino board using a program called the Arduino IDE. You can find this software by Googling Arduino and following the links to the Arduino website. Check the download section of the site and click to download the installer. Installers are available for Windows, Mac and Linux, so pick the right one for your machine. The download shouldn't take long, and then you can run the installer to get things set up. Once the installation is complete, the Arduino icon should appear on your desktop, and you can plug in the board via USB and launch the program. From this window, we can type in code and upload it to the board to see it run. Now we're going to start by loading an example by going to File, Examples, Basics, and then selecting Blink. We'll look at how this example works in a minute, but to start off, I'm just going to click the Upload button in the top bar and have a look at what happens on the Arduino board. So we get a message here to tell us that this is compiling and then uploading, and when it's done, this little LED by this pin 13 starts to flash on and off. Now, I know this doesn't look like much, but it's all being controlled by that software we just loaded, so let's take a closer look at how it works. This is the code we just uploaded. The top section here are comments on what the code is and what it does. The top line here says that it turns an LED on for 1 second, then off for 1 second. The next section down here is called the setup function, and it runs once every time the software starts. In this example, the setup function is only doing one thing, which is setting pin 13 of the Arduino as an output, so that we can send a signal out of the Arduino into the LED to turn it on and off. The final part of this code is called the loop function. It gets run over and over all the time that power is connected to the Arduino. The loop function in the blink example only has 4 lines. The first line says digital write 13 high, which turns the thing connected to pin 13 on. The next line is delay 1000 or wait for 1000 microseconds, which is 1 second. The third line says digital write 13 low or turn the thing connected to pin 13 off again. And the final line says delay 1000 again or wait for another second. These 4 lines of code are going to get repeated over and over all the time that power is connected to the board. To get a better feel for how this code works, let's make a small change and test it. As an example, let's take the delay from 1000 milliseconds and change it to 200 milliseconds, or 1/5 of a second. Since the code will be waiting less time between turning the LED on and off, this change should make the LED blink a lot faster. Clicking upload and taking another look at the Arduino, we can see that the same LED is blinking 5 times faster than it was before. This simple trick is an easy way to control the timing of not just LEDs, but in future videos we'll see how we can use it to control motors as well. Controlling timing will come in handy, but there's only so much you can do with one LED, so let's add another connection to a different pin so we can look at controlling multiple things at once. We can control any of the pins on the board, but let's add another LED to pin 8. The connections for this go between 8 here and ground on the right. Next up, we're going to need to modify the code to control this LED. The first change will be in the setup function. Before we had pin 13 set as an output, and now we need to add another line of code to set pin 8 as an output in the same way. Inside the loop function, let's add 2 new lines, one to turn the new LED on and the other to turn it off. And just to show that these are working independently, let's make the new LED on when the old one is off and vice versa. So while we're at it, let's tweak the delay one more time and change that to ½ a second, and then we can try this code on the board. So I'm just going to click upload one last time, and then by checking out the board, we should see that we now have 2 LEDs blinking alternately. By playing around with the delays, we can create patterns like this, and by adding more pins and more LEDs, we can even create sequences like this one, which would be perfect for some custom Christmas lights.
In this video, we've talked about how to load software onto an Arduino microcontroller. We've loaded some examples and we modified those examples to blink a couple of LEDs on the board. Check out the description for a bit more information, and I'll catch you next time.